Now let's understand Nmos as a pass transistor or a pass gate. I missed one more terminal, which is the substrate terminal. Let me ground this terminal. You know why am I grounding this terminal? Because an Nmos is made in P substrate, and P substrate must be grounded or connected to the lowest voltage possible in the entire circuitry. This is the bulk terminal or body terminal connected to ground. Okay, I just mark it here, and bulk terminal. So what I'm going to do is I'm going to increase this voltage from source from 0 to VDD. Let's see what happens at this drain terminal. Okay, when there is the 0 voltage at source terminal and I have the gate voltage at VDD. Let me have this gate voltage at VDD. The reason why I'm doing this, because I want to pass as much voltage from here to here. So I'll give the highest voltage possible in the entire circuitry to the gate terminal, which is VDD. Okay, so when the source voltage is 0, what is my VTH? Sorry, what is my VGS? VGS is VG minus VS is nothing but equal to VDD minus 0, it is VDD. So my MOSFET is turned on, it will transfer 0 to 0 here. So what must be remembered is the condition for turning on this Nmos, which is nothing but VGS must be greater than VTH, right? VTHN I can call it. So this is the threshold voltage of Nmos. So VGS must be greater than or equal to VTHN in order to turn on this transistor. So what happens when the source voltage is at VDD? Okay, when it is at VDD, my VGS becomes equal to VDD minus VDD, which becomes 0. So this is not definitely greater than or equal to VTH. It is not true. So what happens is the MOSFET will turn off. So it will not be able to pass this VDD to the drain terminal. What is the maximum voltage that it can transfer from here, the source terminal, to the drain terminal? That voltage is nothing but VDD minus VTH. This is the voltage. How can I say that this is the voltage? At that time my VGS becomes equal to VDD, which is the gate terminal, minus VDD minus VTH. Okay, this should be in brackets. So this is actually VG and this is actually VS, right? At that time what happens to my voltage? It becomes VTH. So VGS is equal to VTH. This is the boundary for which my MOSFET has to turn on. So this is the maximum voltage at source terminal which can be transferred to the drain terminal. This is why we say Nmos is a strong passer of 0. It can transfer strong 0, but it cannot transfer strong VDD, because it cannot transfer VDD. It can only transfer till VDD minus VTH. This is the maximum voltage that it can transfer. I'll show it here also. It is 0 to VDD minus VTH. This is the maximum voltage that it can transfer. Okay. The same thing applies to the PMOS as well. We have this PMOS whose bulk is connected to VDD and source drain terminals, and my gate, which is just G, is connected to ground terminal, right, at 0. If I have to turn on this transistor, I have to connect this gate to the lowest voltage possible, which is 0 here. Okay, so what constraint is to be met to turn on this transistor is this VSG, the source to gate voltage, must be greater than magnitude of VTH. I can reverse this terminal by taking the VTH also. So VTHP I call it. Okay, so let's consider the same scenario. I am varying this from 0 to VDD. What's the voltage that I get here? So when it is 0, what happens is my VSG is 0. You see, 0 and 0, VSG is 0. So 0, is it greater than the magnitude of VTHP? VTHP will be usually negative, but even though it is negative, the modulus is definitely greater than 0. So this is not a greater than a positive value. 0 is not greater than a positive value. That this positive value is itself VTHP. Okay, magnitude of VTHP. So what's the minimum voltage that is required to turn on this transistor, PMOS transistor at this source, it's VTHP. If it is VTHP here, the VSG, then only it will be greater than or equal to, I can make it equal to also, so it will be greater than or equal to VTHP. At this time, this MOS will be turned on and it will transfer this voltage to here. So what I can say is, it won't transfer 0 to here, it can only transfer VTHP till VDD, because at VDD I don't have any problem, because this VHG will be VDD minus 0, so definitely it is greater than VTHP. The VSG will be greater than VTHP at VDD, so it will transfer till VDD. So it is a strong passer of VDD, or it is a strong passer of logic 1, okay, and a weak passer. It can pass weak 0, it can pass weak logic 0. So what we can conclude from this is NMOS, okay, transistor or NFET transistor can transfer strong logic 0, and PMOS transistor can transfer strong logic 1, and it will transfer weak logic 1, and this will transfer weak logic 0. This is the reason why we are going for inverter structure. In case of inverter structure, I have one PMOS and one NMOS. This is a PMOS and this is NMOS I am having, and this is my input, okay. I have my VDD over here, VSS over here, and this is my output terminal, right? So why are we going for this structure? This is also called as CMOS structure, okay. This is also called as CMOS structure, which is complementary metal oxide semiconductor. What is complementary? NMOS acts as complementary to PMOS, right? That's the way how they behave. So NMOS terminal, the body terminal has to be connected to ground, which is P type, and this this N substrate has to be connected to, or N well has to be connected to the VDD. So this acts like a pull-up circuit which passes VDD when its input is 0. When its input is 1, the output is pulled down to 0, because this is a strong passer of 0, this is a strong passer of 1, logic 1, okay.